I'm Dr. Connie. I'm your host of Mind Your Health podcast. I share my unique perspective both as a practitioner and a patient battling autoimmune condition for over 25 years because I had to figure things out on my own, and my education in my practical approach as a patient allows me to truly integrate it so that you can be whole and the burden of sick care is no longer your own burden to carry. And this is what we help you with in this podcast.
Hey guys, it's Dr. Connie. This is the Ease Method series all about functional yoga medicine and the Ease method that we use to integrate all aspects of your health and wellness. So today's about the S in the Ease, and it's about the somatic nervous system. And we believe movement as medicine. So welcome back to our enlightening journey through the Ease method, because today we delve into the S of Ease, as I said, exploring the somatic nervous system. And unlike the autonomic nervous system, which we discussed in the previous episodes, the somatic nervous system is associated with voluntary control of body movements through our skeletal muscles. So the somatic nervous system, also known as SNS, is a crucial part of the peripheral nervous system that actually plays a vital role in our daily interactions with the environment. And unlike the autonomic nervous system, which manages involuntary functions, the SNS is responsible for voluntary actions and sensory processing. So here's a closer look at its functions. Number one is control of our voluntary movements. The SNS is responsible for initiating and controlling voluntary movements. It does this by transmitting signals from the brain to the skeletal muscles, the muscles that you can control consciously. And when you decide to perform a movement, such as lifting your arm or walking, motor neurons in the SNS sends impulses from the brain to the relevant muscles, causing them to contract and produce the desired movement. Okay? And second is sensory information relay. It's that connectivity. The SNS always plays this crucial role in our sensory information processing. It consists of sensory neurons that carry information from the sensory receptors, like those in the skin, your eyes, your ears, and the tongue, to the central nervous system, which is your brain and the spinal cord. This sensory input includes touch, pain, temperature, and proprioception, which is the sense of the relative position of your body parts. For example, when you touch a hot surface, sensory neurons in the SNS send a message to your brain about the sensation, prompting a reaction. The third thing I want you to keep in mind is the reflex actions. The SNS is involved in reflex actions, which are rapid and involuntary responses to certain stimuli. And although reflexes are automatic, they are mediated by the spinal cord and do not require direct involvement from the brain. An example of a reflex action is the knee-jerk reflex. And when the knee is tapped, sensory neurons send a signal to the spinal cord, which immediately sends a signal back to the motor neuron, to the muscle of the thigh, causing the leg to jerk. Fourth is integration with the central nervous system. The SNS functions as a critical communication link between the central nervous system and the rest of the body. It ensures that the brain can control and coordinate voluntary movements while also staying informed about sensory experiences. So in essence, the somatic nervous system is integral to how we interact with and perceive our surroundings. It allows us to perform intentional actions and receive and process sensory experiences, playing a key role in our ability to respond to the world all around us. The somatic nervous system utilizes two main types of neurons, both motor neurons and sensory neurons, to facilitate the communication between the brain and the body. And these neurons play distinct yet complementary roles in controlling voluntary movements and relaying sensory information. So let's talk first about the motor neurons. So motor neurons transmit signals from the brain to the muscles to initiate a movement. And this process begins in the motor cortex of the brain, where the decision to move is made. And the signal then travels down the spinal cord and reaches the motor neurons. Okay? There are types of different motor neurons, two specific types, upper motor neuron and the lower motor neuron. And the upper motor neuron originates in the brain, which connects to our lower motor neurons in the spinal cord or the brain stem. And the lower motor neuron extends out of the spinal cord and directly innervates the skeletal muscles. And this is what's called the neuromuscular junction, which is the point where a motor neuron connects with the muscle fiber, which is known as the neuromuscular junction. Here, the motor neuron releases neurotransmitters such as acetylcholine, which binds the receptors on the muscle fiber, causing it to contract and produce this movement. Second is sensory neurons. Okay, sensory neurons convey information from the body to the brain, and this information can include touch, pain, temperature, and proprioception, which is the sense of the body position. And sensory receptors are located in your skin, your muscles, joints, and other parts of the body, detect stimuli and converts them into electrical signals. And these signals are then transmitted by sensory neurons to the spinal cord and up the brain. And there's an integration in the brain because once the sensory signals reach the brain, particularly the somatosensory cortex, they are processed and interpreted, and this allows you to perceive and respond to different sensations like warmth of a sunny day or pain from a sharp object. So let's talk a little bit about the interaction between our motor and sensory neurons. There is a feedback loop for the movements because sensory neurons provide constant feedback to the brain about the body's position and environment. And this information is crucial for fine-tuning movements and maintaining balance and coordination. There's also the reflex arc, because in some cases, such as reflex actions and the interaction between sensory and motor neuron occurs at the level of the spinal cord and without direct involvement of the brain. And this allows for rapid response to a certain stimuli. So motor neurons and sensory neurons work together to enable this complex interaction with the world. And motor neurons allow execution of voluntary movements, while sensory neurons provide the necessary feedback about the external and internal environments, ensuring that these movements are appropriately adjusted and informed. And this intricate coordination is fundamental to our daily activities and overall body function. And reflexes are an integral part of the somatic nervous system, representing automatic, rapid response to a specific stimuli. And these involuntary actions are crucial for survival as they often provide quick reactions to potentially harmful situations without the need for conscious thought. Here's an introduction to the concept of reflexes in the context of the SNS. Okay? Reflexes are involuntary, nearly instantaneous movements in response to specific stimulus. Unlike actions that are voluntarily controlled by the brain, reflexes are managed primarily through the spinal cord and peripheral pathways with minimal involvement from the brain. There are types of reflexes, simple reflexes and complex reflexes. Simple reflexes are basic unlearned responses found in all humans, like knee-jerk reflex. And when the knee is tapped, sensors in the muscles send a signal via sensory neurons to the spinal cord, which immediately sends this signal back through the motor neuron to the thigh muscle, causing a contraction. Then there's the complex reflexes. These involve a more sophisticated response and can include protective reflexes like blinking or withdrawing from pain. There are components of a reflex arc as well. The pathway through which the reflex travels is known as reflex arc, typically involving the following components. Sensory receptor, which detects the stimulus like pressure, pain, and the heat, and sensory neuron, which transmits afferent impulses to the spinal cord. And then there's the integration center, usually the spinal cord, where the sensory neuron activates a motor neuron. And then there's the motor neuron, which conducts efferent impulse from spinal cord to the effector. And then there's the effector, which is the specific muscle or a gland that responds to the motor nerve impulse. Okay, so complex, right? So the purpose and the importance of reflexes cannot be minimized because reflexes serve several critical functions, including protection, which is withdrawing from pain, and then maintaining posture and balance, stretch reflexes, and carrying out basic bodily functions like blinking or even coughing. They allow the body to react swiftly in situations where speed is crucial for protection, bypassing the slower conscious response. So there are some testing that you can do in terms of medical assessments. Because reflex tests are a standard part of neurological examinations, abnormal reflex responses can indicate problems in the nervous system and may be used to identify areas of concern in neurological health. There's also reflexes in learning. While many reflexes are innate, reflexes also can be modified over time through learning and habituation, particularly in complex reflexes. So reflexes are a fundamental aspect of the central nerve or somatic nervous system, providing an efficient mechanism for the body to respond quickly to certain stimuli, often for protective purposes. And they showcase the intricate workings of the nervous system and its capacity to react without conscious deliberation, highlighting the body's innate ability to protect and sustain itself. And regular physical activity and exercise, which are governed by the somatic nervous system, play a crucial role in maintaining and enhancing overall health. The benefits of consistent movement extend across various aspects of physical and mental well-being. And here's an overview of these key benefits. Number 1, cardiovascular health. It improves heart function because regular exercise strengthens the heart muscle, improving its ability to pump blood efficiently throughout the body. This leads to better circulation and lower heart rate and blood pressure. And then there is the reduced risk of heart disease. Physical activity helps in managing weight, reducing cholesterol levels, and maintaining healthy blood vessels, all of which contribute to a decreased risk of heart disease, including heart attacks and strokes. Second is musculoskeletal health. Increased muscle strength and tone. Exercise, especially strength training, leads to muscle hypertrophy, the growth and increase of muscle cells. And stronger muscles support better body mechanics, balance, and posture. And then there's the bone health. Weight-bearing exercises like walking, running, and resistive training enhance bone density and reduce the risk of osteoporosis. And then there is the respiratory efficiency, all about breathing. Because regular movement improves the efficiency of your respiratory system, enhancing lung capacity and oxygen uptake. This can lead to better endurance and overall respiratory health. And then there's the metabolic benefits. Weight management. Exercise helps in burning calories, aiding in weight management and reducing risk of obesity. And regulation of blood sugar as well. Physical activity can help regulate blood sugar levels, reducing the risk of type 2 diabetes and benefiting those with diabetes by improving insulin insensitivity. Then there's mental health and cognitive function. Stress reduction is one. Exercise is known to reduce levels of stress hormones like cortisol and adrenaline. It also stimulates the production of endorphins, the body's natural mood elevators. And then there's the improved cognitive functions. Regular physical activity is associated with better memory, attention, and processing speed. It can also lower the risk of cognitive decline and dementia in older adults as well. Then there's the mental health benefits. Regular exercise is a potent remedy for anxiety and depression. It can improve mood, enhance sense of well-being, and provide a natural drug-free approach to managing mental health conditions. Then there's the immune system support. Moderate exercise can boost the immune system by promoting good circulation, which allows the cells and substance of the immune system to move freely and do their job efficiently. Then, of course, there's longevity and quality of life, because regular physical activity is actually linked with longer life expectancy and a lower risk of many age-related health problems, contributing to a higher quality of life in the long term. So the somatic system's facilitation of movement and exercise is not just about physical fitness. It encompasses a holistic approach to health, touching on aspects of cardiovascular efficiency, musculoskeletal strength, metabolic regulation, mental health, and cognitive function. Engaging in regular physical activity is a key strategy for maintaining overall health and enhancing life quality. And movement and exercise have profound effects on the brain health, particularly in enhancing cognitive functions and neuroplasticity. Neuroplasticity refers to a brain's ability to change and adapt throughout life by forming new neural connections. And I just want to go over how regular physical activity actually benefits the brain. So number one is improvement in cognitive function, enhanced memory, and learning. Because regular exercise, especially aerobic exercise, has been shown to improve memory and learning capabilities. This is particularly due to increased blood flow to the brain, which brings more oxygen and nutrients necessary for cognitive functioning. Then there's the attention and concentration, because physical activity can lead to improvements in attention span and concentration. And this is particularly notable in children and adolescents, where exercise is linked to better academic performance. And then there's the promotion of neuroplasticity, growth of new neurons. Exercise stimulates the production of growth factors like brain-derived neurotrophic factor, BDNF, which promotes the growth of new neurons, particularly in the hippocampus, a region critical for memory and learning in your brain. And then there's the enhanced synaptic plasticity, because regular physical activity enhances the ability for the neurons to form new synaptic connections, improving the brain's capacity to reorganize and adapt. Then there's the stress reduction and mental health, because it reduces the stress hormones. Exercise reduces the levels of body stress hormones like cortisol and adrenaline, and lower stress levels are beneficial for cognitive functioning and overall brain health. It also has the ability to mood enhance, because physical activity increases the production of endorphins, chemicals in the brain that act as natural painkillers and mood elevators, thereby reducing anxiety and depression. 4 is reduction in inflammation and oxidative stress. Anti-inflammatory effects can be expected because exercise has been found to have anti-inflammatory effects on the brain, which is beneficial since chronic inflammation is linked to cognitive decline. And then there is the antioxidative effects, because physical activity enhances the brain's antioxidant defense, protecting it from oxidative stress, which can damage brain cells. Then there is the delaying cognitive decline. Regular exercise is associated with lower risk of cognitive decline and neurodegenerative diseases like Alzheimer's and Parkinson's. And the mechanism include improved blood flow, reduced inflammation, and the promotion of neuroplasticity. Then there is the impact on sleep and brain health. Exercise can improve sleep quality and duration, which is essential for cognitive functions like memory consolidation. Good sleep is also crucial for clearing brain toxins and maintaining overall brain health. So movement and exercise play a vital role in maintaining and enhancing brain health. They improve cognitive functions, support neuroplasticity, reduce stress, and protect the brain from aging and neurodegenerative diseases. So incorporating regular physical activity into one's lifestyle can be a powerful strategy for promoting brain health and cognitive resilience throughout your life. Physical activity is a powerful tool for stress relief, exerting positive effects on both the autonomic nervous system and the somatic nervous system. Engaging in regular physical exercise can significantly mitigate the impacts of stress on the body and mind, contributing to a more balanced physiological state. All this aids to a lot of benefits. A simple way for you to move is just to walk or participate in yoga is why we love yoga so much, because it's effective for all the movements, the stretch, the toning, metabolic effects, and all of the above for mental health as well as stress reduction as well. I do hope you enjoyed this episode as much as I have, and I will see you guys all next week. Thanks for joining me. Bye for now.
Thank you for listening to the Mind Your Health podcast. If you enjoyed the episode, we would so much love it and appreciate it if you share it with someone who could benefit as well. as well as to subscribe to this podcast on Apple Podcasts, Spotify, or anywhere else where podcasts are found. And leave us a review. We would be so grateful, and it helps us to reach more people just like you, so you can become more empowered to enjoy longevity and health. You can follow me on TikTok, Instagram, and YouTube at Dr. Connie Chung. And of course, you can subscribe to this podcast for a new episode every single week. Thank you again, and